Welcome to this demonstration. Today, we'll show you how to leverage ontologies, knowledge graphs, and your Lakehouse data, all stored and managed by Databricks, to bring deeper meaning and context to your business information. Imagine you work for an energy provider, a company that supplies gas and electricity to customers. Naturally, you have customers who subscribe to various contracts, and you have agents managing different interactions, such as claims. These relationships can become quite complex and difficult to navigate. By using ontologies, you can structure and understand all of these interactions, giving clear context to your agents and employees. Let's start by opening OntoBricks. When you first open the application, you can start from scratch. If you've worked with ontologies before, you can leverage standards like OWL or RDFS, or import an existing ontology. You'll find established standards available, such as FIBO for financial services, DISC for clinical data, and IF for manufacturing and supply chain. But perhaps more importantly, since not every company has adopted these standards, you can start from scratch by leveraging your existing data stored in Databricks and managed through Unity Catalog. An even more powerful approach is to use your existing business documentation. Many organizations have documents that describe how the business operates, how the organization is structured, and how entities like customers, agents, claims, and contracts relate to one another. Here, we have a PDF document that describes our business model. What we'll do is generate an ontology directly from this document. We can also provide additional guidelines to help the agent working behind the scenes. For instance, we specify that we'd like to create entities for customers and contracts. Once generated, we get a visual map that describes all the interactions between our business entities. By reading the document, OntoBricks identified customers, agents managing claims, contracts, and all the relationships between them. Let me highlight something important. Notice that a customer can only create a claim if they have an active contract. This might seem logical, but as we'll see shortly, it's not always so obvious in the data. Each entity is described by various attributes, such as names, addresses, and other personal information. And between any two entities, we can define one or more relationships. For example, a customer has a contract, a customer has a claim. All of this has been created and generated simply by reading the PDF document. That's the first step. The second step is what we call semantic assignment. We need to connect this theoretical model with the actual data stored in the Lakehouse. Here you can see that the different entities have already been assigned, meaning we've created SQL mappings that gather the information for each relationship. Notice there's a red indicator here. This means the assignment hasn't been completed yet. Let me run an agent that will work behind the scenes, reading the metadata managed by Unity Catalog and automatically creating the correct SQL mapping. Remember, behind each mapping, there are not only the entities themselves, but all their attributes, like first name, address, and other details that need to be gathered correctly. Here's the resulting mapping, matched with all the different attributes. If anything is incorrect, you can easily adjust it. Once everything shows green, the assignment is complete. Now we can move to the digital twin view, translating the ontology from theory into reality by combining it with. Let me search for Jacob Martinez. Here he is. Jacob Martinez has raised 2 claims and has had 3 interactions. Notice something important at this stage. Jacob Martinez has no contract attached, which is unusual. If he was able to raise 2 claims, he should have contracts associated with his account. What's powerful about graphs is the ability to navigate through the data. We can see that each claim is related to a specific contract, and we can drill down into dashboards provided by Databricks to examine the details. This is how you can navigate through the graph and use different dashboards to focus on specific data points. Now, let's take this a step further by leveraging an AI agent. What's particularly interesting is that agents can understand the global context when provided with graph information. By selecting MCP OntoBricks, We provide this graph context to our AI agent. When we ask a question about a customer, the agent inspects the full OntoBricks registry. Since we have multiple projects, including a bookstore, healthcare data, and more, the agent intelligently identifies that this is a customer-related question and focuses on the correct ontology. The agent now retrieves all the graph information. Here's Jacob Martinez with his 2 claims and 3 interactions. It gathers all the relevant data about our customer. By analyzing all of this information, the agent determines that Jacob Martinez has raised 2 claims and has 2 contracts. This is remarkably insightful. If you only look at the raw data, you wouldn't see the complete picture because no contract is directly attached to Jacob Martinez. But the agent, by navigating all the graph connections, identified 2 contracts, a gas contract and an electricity contract. With this complete context, the agent was able to provide an accurate and comprehensive answer. This concludes our demonstration. We've shown how AI agents can benefit from graph-based information to deliver richer insights, leveraging all the data stored in your Databricks Lakehouse. Thank you for watching.